This glowing digital interface represents a common trap in corporate finance. Companies assume purchasing a new treasury management system automatically resolves enterprise liquidity issues. But when the underlying business architecture is fundamentally flawed, the concrete foundation crumbles beneath it, and the software completely fails. This minimalist dashboard displays a massive $50 million available balance, which usually triggers a direct payment release. But watch, that $50 million is physically trapped behind a restricted jurisdiction boundary. Unconfigured for local currency controls, the payment fails, despite the top-line number. When you automate a process without defining explicit authority boundaries, you scale financial exposure. Faster execution without business guardrails simply means you generate errors, fraud, and liquidity breaches at machine speed. The same failure occurs in liquidity planning. Forecasting degrades into mere spreadsheet collection when the underlying data lacks strict source ownership and assumption tracking. Deploying software features without a governed business architecture inevitably replicates existing operational flaws. You end up with the exact same problems, just executed at a faster, more expensive scale. This architectural blueprint, unfurling beneath the enterprise chart, is the Universal Business Process and Resources Model, or UBPR flows. It is a vendor-neutral, structural blueprint designed to map the reality of enterprise finance operations. The core principle of UBPR flows is strict separation. The business process and the resources it requires must be entirely decoupled from the software interface you use to execute it. Instead of evaluating software menus and feature lists, the framework forces you to define verifiable outcomes. You map governed resources and assign explicit decision rights before a single line of code is configured. Fixing treasury failures does not require switching software vendors. It requires implementing a governed enterprise operating discipline that dictates exactly how the software must behave. To build that discipline, we use the canonical hierarchy, branching from the enterprise down to the day-in-life process and edge variations. Zooming into the DIL node reveals a structured canvas, a role-centered business situation producing an observable outcome, independent of any software screen. Take process 730.01, establishing a daily cash position. Its outcomes remain identical regardless of the software interface. But global standardization hits real-world friction. That is why jagged geometric nodes, edge variations, or EdgeFix, attach directly to the clean DIL canvas. EdgeFix explicitly maps mandatory external variables. A global payment process must adapt when it hits, a local capital control, a strict bank cutoff time, or an illiquid currency market. You have to differentiate between a mandatory business variation that requires governance and a historical manual workaround that needs to be retired. If a global digital standard does not explicitly model and govern these local edge variations, it will immediately break upon deployment. The architecture is held together by a non-negotiable rule called people fabric. If a treasury process exists, an accountable human owner must exist. This matrix displays the exact separation of roles. It strictly defines the lanes of accountability: who recommends, who decides, who approves, and who escalates. Autonomous execution is a myth. Automation operates on borrowed human authority. Watch this API call attempt a payment release down the matrix path. It hits a hard limit gate. An accountable owner steps in, instantly diverting the packet into an exception lane for human handling. True financial control enforces least privilege and explicit authority boundaries. Automation without these physical limits merely accelerates non-compliance. Every data transfer between business units operates as a binding enterprise contract of timing, currency, and authority. Here, a data packet moves from an ERP sales forecast into the treasury workstream. As it crosses the boundary, it receives strict value classification tags. Raw numbers are dangerous unless Treasury knows if they are verified actuals, model-generated forecasts, or values pending confirmation. Unclassified data creates false confidence. A high reported balance might actually be pledged collateral, making it useless for funding tomorrow's payroll. Every data handoff requires a minimum contract. You must define explicit failure behaviors, retry protocols, and manual fallback mechanisms for when data is delayed or corrupted. A highly profitable corporate plan will cause a catastrophic liquidity failure if the cash flow data handoff lacks operational accessibility context. Once the business rules and handoffs are defined, You can address the technology quilt, the actual ecosystem of ERPs, treasury platforms, planning tools, and data lakes. Notice this clean array of business nodes? The cardinal rule of systems architecture is mapping applications only after business outcomes and owners are fully defined. Software blocks drop down and snap onto specific business responsibilities. Technology serves the node, it does not dictate the workflow. Traditional IT deployments fail because they rely on point-to-point integrations between applications, completely ignoring the business owner and the governed process. The UBPR Flows architecture preserves end-to-end traceability. An auditor can track a source obligation straight through to its final financial settlement, regardless of how many software systems routed the data. Integration happens at the business node layer. This ensures the technology quilt serves the enterprise contract rather than obscuring it behind vendor dashboards. Operational maturity in treasury management is measured by capability and resilience, not by the deployment date of your newest software. The apex of this maturity model is the Treasury Decision Twin. This is an AI-assisted environment that continuously models liquidity constraints, market scenarios, and funding decisions. But look at this AI core, tightly enclosed within heavy geometric rings. Implementing AI without a pre-existing business architecture creates massive ungoverned financial exposure. An AI agent requires exact guardrails. It must be anchored to a specific day-in-life process, provided strictly permitted data classes, and explicitly restricted from prohibited actions. It also requires a tested fallback state. The moment an AI agent hits a defined exception threshold, execution must immediately revert to human control. Advanced financial automation is strategically safe only when it is enclosed within a rigorous, accountable business architecture. Look at the structural difference between these two models. On the left, the software-first trap, a chaotic web of brittle point-to-point integrations. On the right, the layered flow of the UBPR Flows architecture. Adopting the UBPR Flows architecture allows a treasury department to stop reacting to fragmented banking data. Instead, they proactively protect the strategic capacity of the enterprise. There is a final unifying criteria for evaluating any treasury transformation: the enduring test. Can every material outcome be traced directly to a governed day-in-life process, a trusted data source, a controlled execution, and a supportable accounting effect? Passing this test confirms you have moved past a brittle software implementation. You have built a resilient, globally governed enterprise liquidity engine.